4.5. Probability of two events. When we're looking at two or more events, probabilities can be large and they can be complex. There can be lots of different options. So there are two ways that we can calculate the probability of two events. First way is tree diagram. So this way is pretty hard because you have to draw out every single outcome and kind of analyze your drawing. For some people this is a little bit easier because you can see all the options, but for most people I would say that it's hard and it's a little bit of a longer process. The other way is multiplication. This is very fast and it's easy. I'm going to show you both ways today, just so that you can see the difference in how long it takes to do both ways. So first things first, let's talk about the tree diagram. Even though it's very complicated, it's very logical, and some people like to see that because they can see all the possibilities. So first things first, start by drawing a dot on the left-hand side of your page. Determine each possible outcome for the first event and list them to the left of the dot. Oh, sorry, to the right of the dot. Draw a line from the dot to each outcome. Determine the possible outcomes for the second event and list them around each possible event. From number one, from the first event, like branches from a tree. Then what you want to do is create a summary of all possible outcomes. So let's find the probability of rolling a 2. So this is on a die. And to get heads, tossing a coin. So first things first, we want to draw a tree diagram to see what the probability is of rolling a 2 and getting heads on a coin. So first things first, we're going to start out at the beginning point. We're going to be starting under that dot. And the first thing is rolling the die. So we have 6 different sides. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Just going to make sure all the lines go there. There we go. That's good. And then I need to, from each of these outcomes, I can roll a 1, and then I can toss a heads or a tail. Just like I can roll a 2. I can, when I roll a 2, I can flip a head or a tail. And the same thing for all of the remaining numbers. So head, tail, head, tail, head, tail, head, tail. So I want to find the probability, so the number of outcomes, so that's going to be our denominator here. The number of outcomes in total is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because you can roll a 1 and get a head, roll a 1 and get a tails, roll a 2 and get heads, roll a 2 and get tails, etc., all the way down to 6. So what I want to do is I just want to find rolling a 2 and tossing heads. Oh, went down the wrong path there. There we go. This one right here. Okay, so there's only one possible outcome. So that means that the probability literally is 1 over 12. So that wasn't bad, but I think that we can do better. So I'm going to be showing you this next way, multiplication. So multiplication. First things first, we want to determine the probability of event 1 as a fraction. Remember, they're our friends. And then you want to determine the probability of event 2 as a fraction. And then what you want to do is multiply the two fractions and reduce. So I'm going to take the exact same question, but instead of drawing a tree diagram this time, what I'm going to do is I'm going to say find the probability of rolling a 2 and tossing heads using the multiplication method. So what we want to do is, so the probability of rolling a 2 is going to be 1 over 6. And the probability of tossing heads is going to be 1/2, because it's either heads or tails. So then the probability, so therefore the probability of rolling a 2 and tossing heads is going to be 1 over 6 times 1/2, which is 1 over 12. Luckily, we don't have to reduce anything here. We can just give our final answer as 1 over 12. Having both of these methods in your back pocket will be very helpful, because sometimes when we use the multiplication method, we're kind of losing sight of what's actually happening in reality. So when you have both of them together, you can use both methods as kind of a check for one another. So if, say, I wasn't sure, I just knew that the multiplication method would work, I would do the 1 over 12, but I could just quickly sketch this diagram just to make sure that that answer is right. It's actually very helpful to have both of them, because like I said before, they can verify each other.